out, write the title, adding fractions on both sides. There's a place for the title on both sides. On both sides, write the title, adding fractions. So adding fractions. There's two sides. The title should go on both. Then on the side that has the helpful hints box, one big helpful hints box below the title, we're going to write the basic things we should do in order to add fractions. So in order to add fractions, what's a big thing that you have to have before you can add them together and see what you get? Okay, so each fraction has a numerator and a denominator. If I want to add 1/2 and 1/3 together, okay, what do I just say, like, oh, 2/5? Do I just add everything together? No. Casey? You have to have the same denominator. Remember when we were doing the licorice, it was hard for us to compare the halves and the thirds, but when we cut them into sixths, it looks like they were all split up into the same section. That's because you changed halves into sixths and thirds into sixths, and then all of a sudden everything was in the world of sixths, and it was a lot easier to see everything because they were the same size. So we want to make sure we have a common denominator. So first and foremost, we need a common denominator. And all of a sudden it's not working. Okay. Okay, so common denominator. Then once you have a common denominator, what do you add when you're adding fractions? Do you add the denominators together? You add the numerator and you keep the denominator the same. You made the denominator the same so you could talk about sixths instead of halves and thirds. So you want to keep that denominator, okay, and you only add across the numerator, okay? So we would add across the numerator. Then, when you get your final answer, okay, what do you need to do with your final answer? Good. Sometimes fractions can be simplified, and then we have to do that if necessary. So we're going to simplify if necessary. Oh, sorry, messy writing. Okay. So simplify if necessary. Those are the main three things we have to do. Now you have to understand what each of those means. When it says denominator, which part of the fraction is it talking about? Nope. Okay. When it says numerator, which part is it talking about? Okay, so the denominators or the bottom number in the fraction needs to be the same, and the numerators is where we're doing all the adding, okay, or the top part of the fraction. All right? Any objection to me changing this? Just raise your hand and I'll keep it there for an extra minute or so. Okay, it's fine. Side of your paper has 5 problems. We're going to do 2 of them together. Then you're going to do the next 3 with your shoulder partner. Okay? So the first 2 is what we're going to work on together. We're going to do our work in one space. We're going to write our final answer as a number in the other space. And in the third space, we're going to write a representation of our answer visually. So kind of like you guys did on the homework with the bars where you colored in a certain amount. Okay? But we're also going to use circles and stuff too. Okay? Yeah. He's just going to write it down. That's fine. And after we do the first 2, Corbin, I'll move everything so you can see the rest of them. But right now we're focused on the first 2. Okay. The first one is 1/3 plus 1/2. Do they have a common denominator currently? No. One denominator is 3. The other denominator is 2. Okay? So we want to think of the factors of 3, okay, and the factors of 2, okay? So 3 times 2 would be 6, 2 times 2 would be 4, but then 2 times 3 would be 6. As soon as we find a common factor, that's what we want to use as our denominator. So I'm just going through my times tables for each number until I come across a number that will work, okay? So that means instead of 1/3, I need to change it into something with 6 in the denominator. How does 3 become 6 using multiplication? Times 2. And then remember yesterday when we talked about equivalent fractions, if we do times 2 in the denominator of the fraction, then we need to do times 2 in the numerator, so it's really 2/6. Okay? Then we want to do the same transformation or 1/2. Okay? So we have 1/2, but we want it to become something with 6. So 2 would have to be multiplied by 3, and then 1 would have to be multiplied by 3, making the numerator 3. So having 1/3 plus 1/2, 1/3 can be replaced. Okay? So right here, this is telling me 1/3 can really be written as 2/6. Okay? And 1/2 can really be written as 3/6. Okay, so we said the directions we follow to actually add and get the numerical answer is we keep the denominator, 6, and we add across the numerator. 2 plus 3 is going to give me 5. Okay, so my numerical answer is 5/6. And now I'm going to represent that as a picture. Now on your homework, I'm going to ask you to represent it 2 ways. Sometimes like we did with bars, okay, that show us kind of like with our licorice, it's broken up into this many. And the other with circles. You can see in the back I have a fraction burger on my board, okay. So it has like lettuce, tomato, I don't know, all those kinds of things. And they split up into different fractions. So we're going to represent 5/6 circular. So give yourself a circle for the representation here. Not very good at drawing circles, sorry. And we want to break our circle into 6 parts. If I draw a diameter across, it breaks it into 2 equal parts. Each of those 2 parts would have to have how many parts in it if I want 6 parts in total? 3. So I'm going to try and cut them into like what I can eyeball as 3 equal parts in each one. I know they look okay, but not that good. I'm not very good, I know. Okay, but there's my 6 parts. Okay, why did I draw 6 parts? Because my denominator is 6. That's how many pieces we broke the licorice into, right? How many out of those 6 pieces is my answer representing? 5. So I'm going to go ahead and just color in 5 of them. So then I get a visual idea of what 5/6 really represents. Okay? All right, any questions about adding the fractions together? No? Okay, so next problem. Okay? 2/5 plus 1/2. Okay? So common denominator, what do we think? 10. Good, 10, because 5 times 2 would immediately be 10. 2 times 2 would be 4. 2 times 3 would be 6. 2 times 4 would be 8. And then finally, 2 times 5 would be 10. Okay? So again, I'm showing you this because if you come across one that's more difficult and you can't figure out the common factor, you should go 5 times 2 is 10. 5 times 3 is 15. 5 times 4 is 20. You have a list, and you try and find the first common one that they have. If you don't pick the best one, but you still get one, it'll work. You'll just have more simplifying to do at the end. Okay? So in order for 2/5, okay, I'm going to write it a little differently this time. So we have 2/5 plus 1/2. Okay. You said the common denominator should be 10. Okay. So I'm going to turn this problem so that both of them have tenths in the denominator. Okay. So this has to be multiplied by 2 to become 10, which means the numerator should be 2 times 2, which is 4. Okay. This has to be multiplied by 5 to become 10, so the numerator should be 1 times 5, which is 5. Okay. And 4/10 plus 5/10 is going to give me 9/10. Now, did either of these answers have to be reduced or simplified? No. How come I know that these don't need to be simplified? Ariel? Good. They have no common factors. The factors of 5, none of them are the same as the factors of 6 except for 1, and dividing out 1 is not going to change our numbers. Okay? So for this one, let's go ahead and make like we did yesterday. Okay? Give it 10 spaces. Okay? Yeah, if you want to. You should be able to do both, though. So as long as you can do both. That's why I started with a circle, because we hadn't seen that one before. So there's my bar, or my piece of licorice, like cut into the 10 spaces, and I'm going to have 9 of them in my answer. Okay? So then I have the representation of that. All right, so your job is to complete the next 3 problems with your shoulder partner if you need assistance. Okay, so shoulder partner is like the person sitting next to you sideways. Does everybody understand what you're going to do? Yeah? Okay, so I'm just going to give you guys, let's see, maybe like 6 minutes, like 2 minutes for each one. Okay, and then we're going to put up answers and check. All right? Okay, if you're not finished, it's okay. But have your hand out with you. Let's check our answers quickly. Talk about the drawings, especially the last one. So everyone should be in their seat if they're not already there. Your eyes should be up here. The conversation should stop at this point. Okay? So first of all, notice that for each one I've written out the common factors. So 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18. 3 times 1 is 3. 3 times 2 is 6. At this point, I can stop. Okay, because I found a common factor. That means this one doesn't need to change. And the one that had a 3 in the denominator, Ivan, up here, please. The one that had a 3 in the denominator, I now want to change into a 6. What number times 3 produces 6? 2. Okay, so I'm thinking about multiplying that by 2 to get 6. So this 1 times 2 would be 2. So this is going to give me 6 in the denominator, and 1 plus 2 is going to give me 3. And notice that each of these have a common factor. So if they do, if you can evenly divide each number, so you can divide them without a remainder by the same number, then you can do so, which gives us 1/2. Okay? And you could have any sort of picture that represents half. Okay? Okay. The next one, 2/3 plus 1/4. What did you guys choose as common denominators? Okay, so 12 is the least common denominator. You could have also used like 24 or something, but you just have to reduce more if you use larger numbers, but that's fine. Okay, so they can both be turned into 12. So I can immediately write this if I want, knowing that each denominator is 12. But I can't just put 2 12s over 1 12. I have to change the numerator also. So here it would be times 4 to get 12, so 2 times 4 is going to give me 8. Maya and Jaden, can you make sure that we're all going through this together? And then 4 times 3 would give me 12. So 1 times 3 is going to give me 3 in the numerator, 11 12ths. Okay? So it can't reduce. So 11 12ths. And you should have a picture representation of that. Okay? You can do a long bar with 12 little spots and color 11 of them. Parker, question? Not you. No, go ahead. No, I was telling them to be quiet. Go ahead. You don't have a question. Okay. All right, the last problem, the least common denominator would be what? 4. Now, you could use 8. Okay, you just had more reducing to do. And if we choose 4, that means 3/4 does not need to change. But to make 1/2 something with the denominator of 4, I'd be multiplying by 2, and I'd have 2/4 for a total of 5/4. So then the idea came up, how do we represent 5/4 as a picture? Well, here's the thing. You are split into fourths. So let's say I take a circle, and I split it into fourths. Okay? How many fourths are there in one circle? 4. But I need to color 5 of them. So what do I need? I need a whole nother circle. Okay? I'll still cut it into fourths. Okay? Always fourths because the denominator was 4. And then I would color 5 of them. So that means the whole one would end up being colored plus an extra piece of this one. So this means you get a whole thing plus another section. Okay? When it's top heavy, as Ariel called it. Okay? When the numerator is larger than the denominator. Okay? All right. Take out your orange paper. Yep. Okay. Subtracting. What is the difference between adding and subtracting? Ariel. Okay, raise your hand if you have something to say. Ariel. Corbin. Okay, good. That's the only difference in adding and subtracting fractions is that one you're doing addition and one you're doing subtraction. So the helpful hints are the same. We still need common denominators. Okay. then instead of, once we get the common denominator, we're still going to keep that denominator. That's our denominator. Okay? What do we do with the numerators? What's that? We don't make the numerators the same. We just subtract them. So last time we were just adding across the numerators. This time we're going to subtract the numerators. Okay? So once you've subtracted the numerators and you have your common denominator, you have one new fraction with your subtraction problem done. And what do we have to do with that fraction if necessary? Simplify. So the last thing we're going to do is simplify if necessary. So the cool thing, and this is why we're doing addition and subtraction on the same day, is that they are very similar in how you have to handle them. The only difference is if you are adding or subtracting across the numerator. Okay? So there's going to be more practice with the same idea. So we're going to, again, do 2 together, and then you guys are going to work on the other 3 on your own. Okay? So first, 2/3 minus 1/2. Our denominators are 3 and 2. If I start writing factors, okay, I can see that 6 is a common denominator. Okay? That means I want my subtraction problem not to look like 2/3 minus 1/2. I still want everything to be worth 2/3 and 1/2, but I want the denominators to have 6 in them. Okay? So the question is, this 2/3, it had a 3 in the denominator. How did that 3 turn into a 6? I multiplied by 2. Okay? So in the numerator, I'm also going to multiply by 2, giving me a new numerator of 4. Now notice, if you simplified 4 over 6, what are 4 and 6 both divisible by? 2. And if you divided them each by 2, what would you get? 2/3. They are the same amount. I just wrote it in a new way that allows me to do the addition or subtraction. Okay? So then here, how did we possibly turn a denominator of 2 into a denominator of 6? Times 3. Do the same thing in the numerator, so this is 3. So 4 over 6 minus 3 over 6 is going to be 1 over 6. Okay, keep my denominator and do 4 minus 3 gives me 1. So my numerical answer is 1/6. Okay. We can represent that through circles or bars, just 1/6 of that circle colored in. Okay. All right, number 2 is 4/5 minus 3/10. So our denominators are 5 and 10. And we know that in order to complete this subtraction problem, we need fractions that have the same denominator. So factors of 10, factors of 5. What am I going to choose? 10. Okay. You could choose 20. Okay. You would just have to reduce more at the end because you chose a bigger one. Okay? So I want both of these denominators to be 10. And then I just need to make sure, look at the second one, it didn't even change. So I'm going to keep the 3 also. So it was unchanged. Okay? But the 5 definitely changed, and it changed by a factor of 2. So times 2. And so 4 times 2 is going to be 8. Okay? So I have 8 over 10 minus 3 over 10. Which gives me what over 10? 5. Good. Then I look. Okay, for 1/6, I didn't do it because the only factor of 1 is 1, so there was nothing to reduce. But 5 and 10 can both be evenly divided without a remainder by the number 5, which would give me 1/2. Okay? All right? Is that okay with everybody? Questions then? I heard a no. This last one? Which part of it, Billy? Okay. So with your method, you would have chosen 50 as the denominator? And you can do that. You chose 10 still? Okay. So the 3/10 stays the same. Are we okay with that? Okay. So here, it had a 5. In order for the 5 to be transformed to 10, we would have multiplied by 2. So we need to do that same multiplication in the numerator, or else we've just changed a number in the problem and haven't done it mathematically correct. So the 4 times 2 is going to give us the 8. Okay? The denominator stays the same. This is all about tenths. If you had 8 out of 10 pieces, so let's say I cut a piece of licorice into 10 pieces, right? Instead of giving you all 10, I only gave you 8 out of the 10. So you had 8 tenths. Then you ate 3 of those pieces. So you had 8 little tenths on your paper. You ate 3 of them. So you had 8 pieces. 3 of them are gone, now leaving you with 5. Still tenths, because that's what I originally had cut the licorice into. So 5 tenths. So your answer is 5 tenths. But we want to write it in the most simple way. And because 5 and 10 can both be evenly divided by 5, we do so to get the smallest pair of numbers we can in our fraction. Is that okay? Okay. All right, so your job will be to complete number 3, 4, and 5, and this time with your front-back partner for the picture part of it. Okay, pause for a minute. I'll go back to 3 and 4, but there was a special request to look at number 5, so I want to do so. First of all, what is the common denominator you can find between 8 and 3? 24 is one of them. So for 8 to become 24 times 3, so 3 times 3 will be 9. And for 3 to become 24 times 8, and 2 times 8 is 16. So I expect my answer to be 24ths. Okay? Now, I have to do 9 minus 16. Good. It should be negative 7, because it would be like 9 positives, and you're trying to take away the 16 positives. There's not enough. So negative 7 24ths. Now, see how this is gray down here? Okay. I know. I don't know why your handouts didn't turn out gray. But go ahead and shade that one in. And here's why. There's not really a way for us in the context of how we've been representing fractions to represent a negative 7 24ths unless you showed somebody this is what 7 of 24 looks like. That's how much you don't have. Okay? That's how much you owe somebody or something like that. Okay? So we're not going to draw a picture when it comes out to be a negative value.